Hello everyone, I am Bhargav and I am going to teach pulse and digital circuits, and this is the first class, so we will see the introduction for the subject. So before going to see the exact syllabus of the PDC, some prerequisites are required and we need to know about the components resistor, inductor and capacitor. So we know very well about the resistor. Resistor circuit symbol is given like this, and resistor R, if you apply certain amount of voltage across the resistor R, then the current I flows through the resistor, and current I flows from higher potential to lower potential for the resistor, and the relation among these three, that is voltage V, current I and resistor R, is given by Ohm's law, that is V is equal to R into I, and this is similar to the linear equation y is equal to mx. So we can able to tell that resistor is a linear element, because whatever the voltage you are applying, whether you have taken voltage on the x-axis or y-axis, if you take voltage on y-axis, then R will become slope. If you take voltage on y-axis, R will become slope, and if you take voltage on x-axis, 1 by R will become the slope. So whatever it may be, if you take voltage on x-axis and current on y-axis, the slope is constant. Okay, at constant temperature, if you perform the experiment, the resistance is the constant, so that you can able to tell that y is equal to mx is followed by this particular voltage current relation of the resistance. Okay, so we can able to tell, because it is a straight line passing through the origin, the characteristics of the voltage and current of the resistor following the linear relationship. That's why resistor is a linear element. So this is the conclusion we can able to give here. Resistor is linear element. Okay, and resistor cannot able to store the energy. Resistor cannot able to store the energy. Okay, resistor dissipates the power in the form of the heat. Okay, so these are the fundamental points we should know. Okay, then coming to capacitor, and we are going to deal with the capacitor a lot compared to the inductor. So we'll concentrate on capacitor first. So capacitor is the energy storage element. Okay, and capacitor is measured in farads, resistance is measured in ohms, and capacitor is measured in farads. So these things already we know, but just for the completeness I am revising all the things. And as the capacitor is the energy storage element, it can able to store the energy in the form of the electric field. Generally inductor can able to store the energy in the form of the magnetic field, and capacitor can able to store the energy in the form of the electric field. Okay, and the voltage of the capacitor or the current flowing through the capacitor is given by equations. So those equations are like this: I is equal to C into dV by dt, and V is equal to, from this particular equation only we can able to give V is equal to 1 by C integral I dt. So in this manner we can able to give voltage equation and current equation of the capacitor. Okay, and before going to see the discontinuities offered by the capacitor, how the capacitor is behaving for the discontinuous input. Okay, before going to see that particular concept, what we will see in the sense how the capacitor will be charged and how the capacitor will be discharged, and is capacitor linear element or not. If it is linear, why it is linear, all those things we will see. Okay, capacitor is basically linear element only. Okay, capacitor is linear element only. Why? How to tell that one? We have said that resistor is a linear because the voltage and current relationship is a linear relationship, and capacitor is also linear element because whatever the charge accumulation is there on the plates of the capacitor is actually proportional to the voltage applied across the resistor. Okay, if you take this proportionality, then you need to put one constant that itself is the capacitance of the capacitor. Okay, so Q is equal to CV and C is the constant, so it is looking like again Y is equal to mx. So if you draw the graph in between charge and voltage, it is again a straight line passing through the origin. Okay, so that what we can able to tell in the sense, capacitor is also a linear element. Okay, and then what are the rules for the charging and discharging of the capacitor? The capacitor can able to charge or discharge within a closed loop only. capacitor can able to charge and discharge in closed loop only. Closed loop means current can able to flow. Okay, current is not equal to 0. Okay, so when current is flowing, then only the capacitor can able to charge or capacitor can able to discharge. That means within the closed loop only it is possible. Okay, then charging occurs when capacitor voltage is lesser than the supply voltage. Okay, charging means capacitor is taking the energy. That means the capacitor should have the lower energy, lower voltage compared to the supply voltage. And discharging can be done when capacitor is having more voltage. Okay, discharging is nothing but capacitor is acting as a source at that particular time. That means capacitor should have more voltage. So when Vc is greater than Vs, or sometimes when Vs is 0, okay, then capacitor starts discharging and that energy is given to the resistors available in that particular circuit. So these are the important points we should know regarding this particular capacitor. Okay, then very important point is capacitor does not allow sudden changes in voltage. How to tell that one? Actually, already I have given the current relationship for the capacitor, current and voltage relationship, that is current I is equal to C into dV by dt. Okay, so here we are applying for the capacitor. This is a circuit symbol for the capacitor. Two plates we are representing for the parallel plate capacitor. Then if you apply certain amount of voltage across this one, it cannot able to charge immediately. Okay, what is the reason for that one? Okay, for example, I have applied the step voltage. So this is the time axis and here certain amount of voltage I am taking, and the voltage is suddenly increased. The voltage is suddenly increased from 0 volts to 5 volts like this at t is equal to 0. So you have applied this particular voltage to the capacitor, then what will happen? If you apply dV by dt, okay, here current is equal to C into dV by dt is there. So I am calculating dV by dt. So dV by dt, if you calculate at this particular portion, you will get 0. Because there is no change in voltage with respect to time. It is 0 voltage only. So 0 is the constant. So constant derivation with respect to time is 0. And this side, that means right side also you have 5 volts. So if you calculate dV by dt, again you will get 0 only. With respect to time, if you calculate the difference in voltage, you will get 0. But if you calculate dV by dt exactly at t is equal to 0, what is happening you observe. Why I am concentrating at t is equal to 0? My intention is what is the behavior of the capacitor at a discontinuity, because in this particular signal representation I have the discontinuity only at t is equal to 0. So I am calculating at t is equal to 0 what is the dV by dt. So dV by dt means the change in voltage, that is from 0 volts to 5 volts there is a change. So after the discontinuity I have 5 and before the discontinuity I have 0. By this change from 0 to 5 happened at t is equal to 0 only. So 0 minus 0 we have to take. There is no time duration. Okay, within the very little amount of time, or we can tell where suddenly the voltage has been increased from 0 volts to 5 volts. That means within 0 amount of time. Within 0 amount of time, the voltage has been increased suddenly from 0 volts to 5 volts. So there is a change in the voltage. That is 5 minus 0, but there is no change in time, that is 0 minus 0. 0 is the time change. That's why we will get here dV by dt is equal to 5 by 0, that is infinity. If dV by dt is infinity, what is I? I is equal to C into dV by dt, that you are going to get infinity. It is not possible. So practically what is happening means when you have the discontinuity in the voltage which is applied across the capacitor, it will not allow that particular sudden change in the voltage. That means capacitor is not responding for that particular sudden change. Okay, whatever the voltage is there previously across the capacitor, same voltage will be maintained after the discontinuity also. So keep this in your mind. That is nothing but at t is equal to 0, discontinuity has been available. Before t is equal to 0, if the capacitor voltage, okay, capacitor voltage before t is equal to 0, for example, it is 2 volts. Okay, example purpose I am giving. So at t is equal to 0, discontinuity is there. Okay, for example, either in this particular case only we have 0 volts, for example. Okay, before t is equal to 0, 0 volts is there. Across the capacitor, how much voltage is there? Before t is equal to 0, 0 volts is there. At t is equal to 0, actually you have applied 5 volts. Suddenly you have applied 5 volts. Even though you apply 5 volts suddenly at t is equal to 0, t is equal to 0 plus means after t is equal to 0 only. So at t is equal to 0 plus also the voltage across the capacitor will be equal to 0 volts only. It will not take 5 volts. Okay, there is no change in the voltage across the capacitor at this particular discontinuity. After the discontinuity, before the discontinuity, same amount of voltage is maintained by the capacitor. So with this analysis we can able to give the conclusion that capacitor does not allow sudden changes in voltage. Capacitor does not allow sudden changes in voltage. This is the key point you have to remember. Okay, to understand the low pass filter or the high pass filter operations also, you should know about the capacitor action. Capacitor does not allow sudden changes in voltage, but capacitor allow sudden changes in current. That is okay, but it will not allow the sudden changes in the voltage. So these are the important points regarding the capacitor. Thank you.